So what we're going to want to do with this problem in order to graph these system of inequalities is to first isolate the variable y in both inequalities. And then at that point, we can use our graphing calculator to help us. So let's take a look at the first one here. First, we're going to subtract 3x from both sides of the inequality. So we'd get 2y is less than or equal to negative 3x plus 14. Notice that's the same thing as 14 minus 3x. I just like to do it in proper order with the variable term in front of the constant term. At this point, then we can divide everything by 2, and we'd completely isolate y. So we'd get y is less than or equal to negative 3 over 2x plus 14 over 2, which is, of course, just 7. So this is our first equation that we're going to input in our graphing calculator. Of course, in the graphing calculator, it would be y equals negative 3 over 2x plus 7. And then what we're going to be looking at is the area that is less than or equal to that line. Now, moving on to the second inequality, 4x minus y is less than 2. Now, to isolate y here, we could first subtract 4x from both sides, and we would be left with negative y is less than negative 4x plus 2. And then to make y positive, what we can do is basically write the opposite of each term, and that would be the same thing as multiplying each term by negative 1. And we would get y. Oh, and very important here, because we're multiplying by a negative number, this sign is actually going to change directions. So now it's going to be y is greater than 4x minus 2. This is a very important step that a lot of students would make a mistake on. Remember that when you're manipulating an inequality, you have to multiply or divide by a negative number in order to solve it, that the inequality symbol is going to switch directions. So now at this point, you can grab your graphing calculator and input both of these. Now, just for fun, I'm going to actually do it without using the graphing calculator, and I can do that pretty easily because we know the slope and the y-intercept of each inequality. The first one we know has a y-intercept that's 7, so 2, 4, 6, 7. So we know it's right here, and then we know the slope is negative 3 over 2. That means the next point would be 3 down and 2 to the left, which is right here, and then we can just keep following that pattern. Now, because the inequality is y is less than or equal to this line, we can actually draw a line connecting them. Oop, I'm a little off there. And it can be a solid line because the solution set includes that line. And then I'm going to highlight everything that is below that line. So all of this here is part of that solution set. Now looking at the other inequality, y is greater than 4x minus 2. Well, for this one, it has a y-intercept at negative 2 and a slope of positive 4. So that means we're going to move 4 up and 1 to the right to get to the next point. 4 up, 1 to the right. 4 up, 1 to the right. Now, for connecting these dots, I'm going to be careful to not draw a solid line because the solution set does not include the line. It has to be greater than it. So I'm going to draw a dotted line instead to represent that. Okay, like that. And the solution set of this one is that y has to be greater than that line. So we're going to highlight everything above that line, like so. So the actual solution set of the system, a system of inequalities, in other words, both inequalities, is the area in which we are both highlighting green and purple in this case. And I'm going to use a different color. I'm going to use red here. So we can see that this whole red area is our solution set. And it includes the line, the purple line, but does not include that green line. Now, for the last part of the question, we're asked to determine if the point 1, 2 is in the solution set. So let's go ahead and find it. 1, 2. Let me just zoom in here. So you can see the point 1, 2 is right here. And you may instinctively think, oh, that is along the green line, so that's part of the solution set. But remember, we've talked about how the green line is dotted, which means that actual line is not part of the solution set. It's outside of it. So you can see my written conclusion here. I said that the point 1, 2 is not part of the solution set since it is on the dotted line. In other words, it doesn't satisfy the inequality y is greater than 4x minus 2. It would be part of the solution set if y was greater than or equal to 4x minus 2, but that's not the case. Anywho, that would be it for this video. Hope that helps, and thanks for visiting JD's preparation.